Hi, everybody. This is Eric. Welcome back to Reading the F and Docs, where we are learning Solidity together. And we are still in our Solidity by example, sample contract section in the basics. And last time we went over the simple open auction contract, and today we're going over the follow-up, which is the blind auction contract. And I already went ahead and opened this and remixed. I also made some notes here. But basically, what's the difference between this and the regular auction contract? Well, so this is a blind auction. So what that means is that you and I can bid at the auction, and our bids are hidden. Nobody knows how much we bid until a certain time. So this auction happens in phases. There's a bidding phase, the reveal phase, and then the end of the auction. So during the bidding phase, our bids are basically obfuscated, so nobody can actually see what we bid. And then when it comes to reveal phase, then it's revealed that who bid what, who won the auction, etc. Now, question: how can we hide our bids when everything in the blockchain is open, it's published, it's out there for anybody to inspect? Well, the answer there lies in cryptography. So there is a common design pattern in cryptography called the commit reveal pattern over there on line 169. And basically what that means is essentially kind of what we described. You doesn't have to be an auction per se, but you commit something, in our case a bid, but nobody knows what it is except for you. And then at a later time, you reveal it. So how that happens is, if number one, by the way, we don't need to get PhDs in math, but if we're going to be blockchain engineers, we should have a fundamental basic understanding of a lot of, cryptographic concepts and primitives and so forth. So one of them is this design pattern I just discussed, and what facilitates that is another cryptographic primitive called Keshack 256. Now that's one of several hashing algorithms, and we're going to play around with it right now. So how that works is, you might have seen that before. Solidity even comes with a function that you can use to create a Keshack 256 hash. And because we're playing with the console, we're going to use the ethers.js version of this function. But it takes in a bytes, a bytes object instead of a string. So inside of this, I'm going to call another utility function where I'm formatting my string to bytes. But let's give you an example here. So if we put in, let's say, hello world, this is going to return to us a hash based on our input. And if we change one thing, we make world from uppercase to lowercase to W, you can see this gives us a completely different hash. And if we put it back to uppercase, this returns the same exact hash as the first one. So the point is, any input you put in will always generate the same output, and the smallest difference in that input will generate a completely different output. And it's irreversible, meaning I can't take one of these hashes and try to reverse engineer what the inputs were. So this is a very powerful concept, a very powerful tool. You see it all the time in in the blockchain space. And so that's what we're using here, and that's how we are obfuscating and hiding what our bids are. Now, there's one other part to this, which is, so for example, what we're doing is so our bid is going to have three elements. It's going to take in a value, which is how much you want the bid to be. It's going to take in a Boolean flag called fake. So, is this a real bid or a fake bid? And it's going to take in a secret, like a password. And this is going to help us, come up with a random thing. Now we got to think this concept of fake bid and why we have them. So now one thing we can't hide is the amount of ether we sent with the transaction. So that's going to be there on the blockchain. So anybody inspecting this contract and the transaction logs, they can tell who sent how much ether. But what we can do as bidders is we can make multiple bids, and we can flag them as real or fake, and we can put in varying amounts of ether. So if I place one bid for $1,000, but label that as a fake bid, and then put in another bid for $100 and label that as a real bid. But whether it's fake or real, that is hidden or obfuscated. Whereas the actual amounts that I bid are there for anybody to read. So we basically fool people by, switching it up, sending multiple bids, and some bids are real, some bids are fake, and that's how ultimately we are creating a blind auction versus a regular auction. So those are some of the concepts that we need to understand before we get into this contract. But let's go ahead and compile this. Okay, so we're gonna try this again. I messed up interacting with the contract. All right, I made a mistake interacting with the contract, so I'm gonna start this section again. Let's go ahead and compile our contract now. And let's deploy it again. Now, before we deploy, let's get let's see, bidding time. I'm gonna make it 2 minutes. Let's make it 90 seconds actually. And then reveal time, we're gonna let it be again 90 seconds. Oops. Our beneficiary address is going to be our address. Now, before we deploy it, let's get our act together in terms of what we're going to pass in as input. So let's set the first one to 1,000. This is going to be a fake bid. Let's say 1,000 true. All right, let's go ahead and deploy it. So now we have to hurry up because we only have 90 seconds to do this. So this is our fake bid. We need to pass in some, I am grossly overpaying for these things. Just I don't want them to error out. Let's paste our bid there. Now this is going to be a real bid. Our hash. Make sure we add some money there. Hope it works. Okay, great. Just in the nick of time. So we're able to place our 2 bids. Now, next up, after 2 minutes passes, which maybe it already passed, or 90 seconds, we're going to have the option to reveal our bids. But what we need to do is pass in our value. So the first one was 1,000. The second one was 5,000. The Booleans were, let me see, I think they were true and then false. That's right. So, oops. True, false, and then we passed in. We kept the secret the same both times. And let's see if it lets us reveal. Let's see. The function has been called too early. Really? It hasn't been 90 seconds? Okay, let's try it again. There we go. And the reveal happened. So the reveal doesn't actually return anything. What it's doing is it's gonna then give us the ability to withdraw. Let's see. So because we called reveal, the highest bidder is now, calculated. Let's see, auction. Oh, better call auction end. Let's see, beneficiary is us. End is here. Ended has not been called. We might have to wait until yeah, we have to wait until the reveal period is over. So maybe it's been 90 seconds now. Let's try it again. Auction end. Oh, still calling too early. Okay. And let's try it again. Might have to fast forward this too. But we can also check, hey, what were our bids? That's another thing we can do here. So here's our address. The bids, let's see, our first bid was that hash. Oh, no, that's giving us a 0 address. Okay, we're able to call auction end. And now we can see who is the highest bidder. Well, I already calculated that, so that's us. We can reveal the end. Oh, that just tells us the time. And now we can withdraw money. And that's how it works. So let's dive into the code here. Go ahead and open this. Oops. Make some room here. All right. So now, I've said it before, any smart contract is essentially just a state machine. And let's look at what state do we have? We have an address of beneficiary. That's just the person who receives the money at the end of the auction. Now, remember, this auction happens in phases, so that's where these variables come in: bidding end, reveal end. This ended flag, meaning is the auction over. So this mapping is our actual bids. So, and each bid takes the form of the hash we made, which is blinded bid, and the deposit, which is the actual amount of ETH that we sent. So that's our mapping called bids, and each user, each address gets their own array because they have multiple bids. Okay, so then we keep track of, and once we, reveal our bids, that's when the highest bidder and the highest bid is going to get calculated. That's also going to add this that's also going to create this pending returns array. So each person who bid, if it was a fake bid or if it was a bid that wasn't the winning bid, they're going to have the right to take their money back after, at the end of the auction. And then we have, custom event, auction ended. We have some errors. But this is basically our state up here. And that's what we're interacting with. We have a couple of modifiers: only before, only after. So because these are, time situations and time phases, these are the things that we're going to use to enforce certain actions can only happen during certain points in the lifespan of this auction. So what's happening here in our constructor? So we're taking in a bidding time and a reveal time. If you remember, I was adding in 90 seconds or 2 minutes. This is basically the length you want the bidding phase to be, the length you want the reveal phase to be, and this is the beneficiary address. We put in our own, but we can put in somebody else's, and this just initializes those variables. In this case, it's adding the time to the current time, and then this is adding that time to the other time. So now our bid function, the initial bid function, all it does is populate this bids array. So it just creates a bid object or a bid struct using the hash we sent in and the value we sent along with our transaction. And that's going to give us our entry into the bids array. And then we'll go over this reveal in a second. And then we have our withdraw function. So when it comes time that you're allowed to withdraw, I mean, this may not do anything at first, but if your bid is not the winning bid, then this is what this is what allows you to take it back. Now we have so this, we might have seen this before. This checks affects interaction pattern. This is also a standard best practice when you're writing Solidity code. It's to prevent against reentrancy patterns, and it basically refers to anytime you call something like this, like you're calling an outside contract, or in this case, we are transferring money. We want to do that after, we update our balances, because otherwise someone can call this withdraw function multiple times and, drain the contract of funds that they don't deserve. So, as you go along through, your Solidity development journey, you're going to see that concept of reentry attack often, and you're going to get well versed in how to prevent against it. Auction end, this is what we call to officially end the auction, and then that will send the highest bid to the beneficiary. Again, we're checking to make sure that we can only call this after the reveal. If it's already ended, this is going to set the ended flag, so we can only call this once. We're going to emit an event saying, hey, the auction ended, and these are the stats. And then again, the last part here is us actually transferring the money. And then what else? We got place bid. So this is internal function that's called by reveal. But what this function actually does is it returns true or false. You can see here, return success, takes in the bidder and the value, and the value being, the value of the bid. If it's less than or equal to highest bid, then we return false. If that highest bidder is not the zero address, then we update this pending returns highest bidder object. So this is what's actually updating that pending returns object. And this is where, it's determined how much you can withdraw back once the bidding has completed. And then, but in the case of the highest bid, then, then the values of highest bid and highest bidder get set or reset. So that's what we're doing here. And let's go to the actual reveal function, because this is where the bulk of the action is. So this is taking, remember before we were putting in values of all the bids we made in 3 separate arrays. We put in all the values we passed in, all the fakes we passed in, flags, all the secrets we passed in forms of arrays. We can only call this after the bidding ended, but the reveal ended, which is why I was kind of making sure I did it within that our 90-second time frame. And we're doing our checks, making sure these lengths all match up. And then, we have this refund uint, which will get populated as we loop through all our bids, and, losing bids or fake bids just get added to this refund amount. Ultimately, down here at line 114, the last thing we do is refund ourselves that amount. But within here, in here, look at this, line 100. So this here is when we pass in the values, the fake flags, and the secrets that we initially use to create our hash. Now, instead of passing in the hash, we're passing in the inputs that we use to create that hash, calling this Keshat256 function again. Now, if you remember, if we put in the same inputs, it will give us the same outputs. So now we're checking that against the hash that we initially used to bid. So if they're not equal, nothing happens and we continue. But if they are equal, then the rest of this stuff gets executed, meaning, we increase the refund amounts. If this is a real bid and then the deposit is greater than value, so meaning if we deposited more money than we said we wanted to bid, we refund that back to ourselves too. But we're also in here, place bid is where we're actually checking it to see, is this the winning bid or not? And that's pretty much it. That's the walkthrough of the code. So this was probably the most complicated contract we've come across so far. And it handles a lot of functions, a lot of things in Solidity. We have a struct, use of the time type. We have various data types. We have mappings. We have events. We have custom errors. We're using custom modifiers. We're using the constructor. We're using internal functions that are called from other functions. We are using a Keshat256 hashing algorithm. So there's a lot of features of Solidity that we haven't used before that we're using now. But this is getting closer and closer to the complexity of some real world contracts out there. Not even close to some of the most complex DeFi protocols and so forth. But this is a great contract to study as you're learning. I hope this was helpful. My name is Eric, and I work for CryptoPunks.